Okay, this is the first lesson in Chapter 2. We're going to be talking about congruent figures. The main key idea in this lesson is that congruent figures are figures that have the same size and the same shape. So they're the same in every way. If I were to look at the two triangles given, ABC and DEF, notice that the matching angles are called corresponding angles and they're equivalent to each other. The matching sides are called corresponding sides. The way that polygons are named will help you, and that will be a clue as to how you can match up the corresponding sides. Now these are easy because they're oriented the same way, but we're going to be looking at a lot of polygons that are reflections of each other or some way translated or turned or rotated and might be a little bit different. For these, if I start with the first letter, so triangle A, B, C, and I use the symbol for congruence, triangle D, E, F, one thing that I can point out is if I number them, 1, 2, 3, and I start over. 1, 2, 3. Both angles in the first position, A and D, would be corresponding. Angles B and E would be corresponding, and angles C and F. It would also help you when they're numbered like this to find the side lengths that are corresponding. So AB and DE, BC and EF, CA and FD. So let's see if we can use that on our next example. In this example, it says the figures are congruent, name the corresponding angles and the corresponding sides. The trick here is they have not named it for us, so it's going to be up to us. Let's go ahead and look at this first one, and we'll start with J. We'll make that the first angle. So if we make K the second, third, fourth, fifth, now we have to somehow find a way to spatially translate or transform the other polygon so that the angles would match up. So let me go ahead and name it. So J, K, L, M, and N. And hopefully you're able to see that they're kind of, especially after what we did yesterday with our reflection activity, that it's like a mirror image of the other. So if we imagined it being the y-axis right here, one is reflected over the y-axis and then named differently. So if we reflect it back, you can line up the vertices and it would be S, R, Q, V, and T. So now we have these relative positions. I'll go ahead and number them. Angle 1, 2, 3, 4, and 5. Angle 1, 2, 3, 4, and 5. So we can match up the corresponding angles as angle J and angle S, angle K, the ones that are in the second position, angle R, angle L. Notice the notation that we're using too. And angle Q, angle M, angle V, and finally angle N, and angle T. For side lengths, we have the 1, 2 positions, so J, K, and S, R, K, L, and R, Q, positions 3 and 4, L, M, and Q, V, positions 4 and 5, M, N, and V, T, and then positions 5 and 1, N, J, and T, S. So these are all the corresponding angles and corresponding sides. So identifying congruent figures. It says that two figures are congruent when corresponding angles and corresponding sides are congruent. And you can see this using the angle notation and the tick marks on the sides. Each one corresponds. So here we've talked about the order. They've even used color codes. So angle A is blue and angle D is blue. That's the first one. So those two are equivalent to each other. And in the notation right over here, you can see 3 arcs. And so that would be a way to identify two angles that are equal to each other and in corresponding positions. The blue angles B and E have 1 arc, and the red angles C and F have 2. And then likewise, the side lengths that are congruent, they have like the red side lengths have 1 tick mark, the blue side lengths have 2, and the green side lengths have 3 tick marks. So that's one way that you can tell. Again, if you were asked to name them, like we did in the last example, you can use the numbering system, a color coding system, something like that would help you. But the most important thing to keep in mind is that when you are given the names, you know that they're named in order between the two different polygons. So example 2. Which square in example 2 is congruent to square D? So square D is on the right. We know that all squares have 90-degree angles, so the angles are all equivalent anyway. If I look at square A, it has side lengths that are 8, but square D has side lengths that are 9. Square B has side lengths that are 9, and then just to be sure, I look at square C, and it in fact does have side lengths that are 8. Even though the orientation is the same, we have to go with the congruent side lengths. Remember, congruent means same in every way. So the answer here is square B is the same as square D because of the side lengths, and we know that the angles are the same as well. Final example, these two trapezoids, ABCD and JKLM, are congruent. So they're also oriented the same, which makes it a little easier. We didn't have to do any kind of transformation to flip it, rotate it, or anything to get it in order. And they've named them for us, so that makes it a lot easier too, because we can simply come up here and look at the letters 1, 2, 3, and 4. 1, 2, 3, and 4. So we want to know which angle corresponds in the right-hand trapezoid, the JKLM, that corresponds to C. Well, angle C is the 3rd position, and looking at the name, angle L. So angle L corresponds to angle C. When we look at what is the side length of KJ, well, KJ is the first 2 letters in the 1, 2 position, and AB are the first 2 letters in the 1, 2 position. So KJ must be equal to 8 feet.